Hello everyone, today we are finishing our data and statistics unit with section 7 on least squares regression lines. So a regression line is a straight line that describes how a response variable y changes as an explanatory variable x changes. We're going to use this data set here, which shows the price of Ford F-150s compared to the number of miles driven, as an example for our regression line. So the goal of the regression line is to create a model that can be used to predict values of a response variable based upon an explanatory variable. In other words, if we know how many miles have been driven, then can we figure out how much the truck should cost? So to do that, we have a regression line, and I'm going to zoom in on the formula here. It says if y is a response variable plotted on the vertical side, or the vertical axis, and x is an explanatory variable plotted on the horizontal axis, then a regression line relating y to x has the form y is equal to the population of our y-intercept plus the population slope coefficient times the explanatory variable plus the random error item. So this is our overall formula, which looks pretty messy right now. To simplify it, what we really have is we have the linear, this part is just a linear line. It's that slope-intercept form, y equals mx plus b, mx plus b. And what this is a linear component. And then we have this random error item, and that is the random error component. In this class, we're primarily going to be working with this part, and our equation will look very similar to a y equals mx plus b. And at this point, we're going to switch clips to the calculator instructions, and we're going to use our TI-84 calculators to calculate the linear regression line for this data set, where our miles driven are the x's and our price is the y's. So we're looking at, on our x-axis here, it'll be the miles, and this will be your price. In other words, miles is explanatory, price is the response. And when we come back from that video, you'll notice that this graph will already be filled in and the equation will be written beneath it.
So the first thing you need to do is you need to go to Stat, you're going to hit Edit, and you're going to put your data in your lists. So I already put this in here. These are all my X values and these are my Y values. Then after that, I'm going to hit Second Quit. And we are going to go calculate some things with statistics, but before you can do that, you have to make sure that your diagnostics are turned on. So to do that, you're going to hit Second, and then we're going to the catalog down here. I'm going to hit 0. That brings me into the catalog. I'm going to scroll down until I get to the D's, and I'm looking for diagnostic on. And there it is. I'm going to select diagnostic on, I'm going to hit enter, then I need to hit enter one more time, then it says done. Once you've done this, you don't have to do it again. It'll always give you your diagnostics unless you turn it off, but otherwise it'll stay on. So now that we've done that, we again have our data in our lists, then I'm going to hit stat, arrow over, I'm in calc, and this time I want lin-reg, that's a linear regression model. And that's option 4. You can either hit the number 4 or you can scroll down and hit enter. I need my X list to be my L1 because that's where I put my X's. I put my Y's in L2, so that's what I have listed for my Y list. Frequency list we can skip. We're going to skip this part as well, and we're going down to calculate and we're going to hit enter. And now, because we have our diagnostics turned on, we have our y is equal to ax plus b, where a is equal to negative 0.1629, b is equal to 38,257, and we have 0.135. This 5 is going to round our 3 up, so we are at 0.14. And then we have r squared and our r is our correlation coefficient, which is 0.815. So 0.82 is what our correlation will be. And I'm going to write that down, and I actually pre-wrote it on a sticky note here because we're going to need to put that equation into our calculator so that we can see the visual graph of our scatter plot and of our linear regression line. So to do that, previously we have been graphing lines by going to y equals, and this is where we'll put our regression formula, but our scatter plot is going to come from these plots up here. And I'll show you how to get that in a second. I'm going to start by putting my regression line in. So I have negative 0.16x, and I covered my x up here, plus 38,257.14, and that's my linear regression line. To get to my plots, I'm going to hit second, and right above the y equals it says stat plot. That's what I want. I'm going to use the first one. I'm going to hit enter to select that. I'm going to turn it on by hitting enter. I'm going to go down. If you don't have this first graph option selected, that's the one you'll need to pick. Then I have my X list in L1, my Y list in L2, and then you can choose which kind of dot you'd like to use to show you the scatter plots on your graph. Now that we have that, if I hit graph as is with a normal standard window, it's not going to look quite right. In fact, we don't see anything at all. In order to see our graph, you're going to hit zoom, and this time we're looking for zoom stat, which is number 9. I'm going to hit enter, and there's my scatter plot, and there is my regression line as well.
All right, now that we used our calculator to find our regression line, which was y is equal to negative 0.16x plus 38,257.14, and our correlation coefficient of negative 0.82, which is saying that when we look at our graph, we have almost a straight line. It's a pretty strong correlation, and it is a negative correlation. And this is a quick sketch that I drew of the graph that we found, our scatter plot, and this is my regression line here. So now that I have those pieces, I can use all of this information to solve and make predictions for the price of a F-150 depending on the number of miles. So let's go ahead and look at some examples here. Number 1 says predict the cost of a Ford F-150 with 62,000 miles on it. So we're going to need to use our formula that we just found. So y is equal to negative 0.16 times our x, and we said that our x was the miles, not the price, it's the miles. So if I'm going with 62,000 miles, that's what I plug in for my x. So I have 62,000 plus 38,257.14, and I actually already typed this in my calculator, so if you type this whole thing in your calculator, it should give you that y is equal to 28,337.14, and this is the answer that it gives you, but we're predicting here, so this is an estimate, so our answer is actually going to be that it will be about $28,337.14. And I'll get my dollar sign in there. I'm going to rewrite. There we go. That's better. And that is my final answer because we're predicting the cost. All right. We also have a Ford F-150 is for sale for $18,999. Predict how many miles might be on it. So I have this as my cost. That's my y. So when I'm typing this into my equation, I have 18,999 is equal to negative 0.16x plus 38,257.14. From this, I'm going to subtract my dollar amount out, so I'm subtracting 38,257.14 from both sides. And that leaves me with negative 10,258.14 is equal to negative 0.16x. Going to divide out negative 0.16, which means that the number of miles, that's our x, is 120,368.38. And in our answer, I'm going to say that that is about 120,368.38 miles. Make sure you are labeling what that is. All right, number 3 says to protect the cost of Ford F-150 with 270,000 miles on it. I'm not going to go through this one because it's exactly the same as question number 1. So we're going to skip that. Number 4, I will say you can find the answer on the sheet that I will upload into the Google Drive folder. Number 4, interpret the slope of the regression line in the context of the problem. So our slope of the regression line is the part right in front of the x, negative 0.16. So this is saying that as each mile is added, the cost of the car is going to go down. The value is decreasing by this scale. So as the number of miles increases, and this is the slope because we have a negative slope right here. So as the number of miles is increasing, the cost is decreasing. And that's what our interpretation will be. So as the number of miles increases, the cost of the F-150 decreases. And then number 5, interpret the y-intercept of the regression line in the context of the problem. So our y-intercept is 38,257.14. So what this is saying, because it's our y-intercept, and that would be right about here, is that when you have driven 0 miles, this is what the cost of the car will be. So a brand new car with 0 miles will cost $38,257.14. Let's go ahead and write that down. At 0 miles, the F-150 costs $38,257.14. All right. We have one more example of a linear regression model. We're going to switch the page here. This question says to refer to the table below to answer the following questions. So we have the number of people in a party and the bill for the dinner. So if one person attends, then we pay $8.50. 3 people, $29.30. 5 people, $63.75, and so on. Then we also have this LSRL equation. In other words, that is your regression line. It is the least squares regression line. That's what the LSRL stands for. And we have y is equal to 1650 plus 8.51x. And just to clarify, that means that our people is our x and the bill is the y. So we have x and y. I'll rewrite that. So number 1, it says, what is the estimated bill for a dinner involving 7 people? Well, there were 7 people, and that was our x, so we're going to take that and we're going to plug it into our equation. So I have y is equal to 16.5 plus 8.51 times 7. When we type that in our calculator, that means that our bill is going to be approximately $76.01. And I already typed that in to get that answer. Number 2 says, what is the estimated bill for a dinner involving 14 people? I'm not going to solve all the way through with this one. You can see the answer in the notes. But again, you're taking that and you're plugging that in. So you would have 16.5 plus 8.51 times 14, because there was 14 people. Number 3, if the total bill for a dinner was $110, how many people do you estimate were at the party? So that means that we're taking our formula, and this time we know the total cost, that's our Y, and we have to figure out the people. So we have 110 is equal to 16.5 plus 8.51x. So we're going to start by subtracting 16.5 from both sides. That leaves me with 93.5, and that's equal to 8.51x. I'm going to divide out 8.51 from both sides, which means that there were approximately, and this actually totals 10.99. We can't have 0.99 of a person, so we're going to say that it is about 11 people, and we're rounding up to get a whole person there. All right, number 4, interpret the slope of the equation in the context of the problem. So we are saying in our slope, if we look at the slope itself, it's a positive 8.51. It's right there in this question. And that means that our line is increasing. So as the number of people increases, the bill is going to increase. So as the number of people increases, the bill, or the total bill, also increases. Interpret the y-intercept. Our y-intercept was $16.50. So what that is saying is if you go to the restaurant, well, it's saying if 0 people go to the restaurant, they're already paying $16.50. So at 0 people, the bill is $16.50. So a situation where that might be, where it might make a little more sense is rather than saying at 0 people in the restaurant, that might be if you go to the restaurant and you sit down and 0 people order any food, but they charge you $16.50 just for sitting at the table. That might be something that you could see. Number 6 says, look at a scatter plot and estimate the correlation. So I actually already plugged all this data into my calculator and ran the scatter plot in the graph and the regression line on the graph, and it looks like this. And I'm going to take that and I'm going to sketch it onto my paper here, and then we will estimate the correlation after that. So I have this graph. The line starts up a little ways, and it's kind of on a steep incline, so it looks something like that. Then we had a data point down here, one really close to being on the line, one above the line, right there. There we go. We have another one close to the line, another one right there, about there, one up here, and then one over here. So that is what our scatter plot looks like. If I were to estimate the correlation for this, I would say that we're probably about 0.8. We're pretty close to the line. I see a pretty strong trend, but we're not exactly on the line, so we can't be at 1. It is positive, so we're going to say that R is probably about 0.8. That's my estimate. And when you're estimating a correlation like that, you should be close. It should be positive if it's positive. It should be negative if it's negative. And your number might be a little off from mine, but you need to be close in order to get full credit. So if I'm saying that this is 0.8, it's pretty strong. If you give me 0.5, 0.5 means that there's a pretty moderate pattern, which would imply that these dots are scattered out a little further. So you should be probably within 0.1 or 0.2. All right, and how would you describe the relationship? I would say that as this has about a 0.8, we said it was kind of strong. We already said it's positive. We already know it's linear. So I'm going to say that this is a strong, positive, linear association, and I'm not really seeing any outliers. Maybe this one right here, but it's still pretty much on trend, so I'm going to say no outliers. All right, this is where we're going to stop. This is the end of our section and our unit. And we'll pick back up with Unit 8, which covers triangle similarity.